In this video, we will determine if this function is even, odd, or neither, and we're talking about symmetry. Well, we will know at a glance if this is even, odd, or neither, because if it is even, all of the exponents will be even. If it's odd, all of the exponents will be odd. If it's neither, there'll be a mixture. So let's look at it. So I see an exponent of 3. Having just an x is like having x to the 1 power. And having just a 5 is like having 5x to the 0 power, because there are 0 x's here, and there's 1 x here. Okay, now here's the thing. 3 is odd, and 1 is odd. But 0 is even. So we have odds and evens. That means this function is neither even nor odd. Alright, so we already know the answer. But let me also show you, sometimes you have to prove algebraically whether or not this is even, odd, or neither. And the way you do that is by substituting in negative x. Okay, if you put in negative x and you get your original function back, then that's when it is even. If you put in your negative x and you get the opposite function back, that's when it is odd. And of course, if neither thing happens, then it's neither. So we can look at that. So we have our original function, looks like this. But how about the negative function? The negative function would look like this. Negative 2x to the third power minus 4x minus 5. So this would be the negative version. Okay, so let's substitute in f of x, let's substitute in negative x and see what we get. So if I put in negative x, so that's negative x to the third power plus 4 times negative x plus 5. Let's see what we get. Well, if you have an odd exponent, the negative stays negative. So I'm going to wind up having this negative, which I'll put out front. So I'll have negative 2x to the third power. This doesn't even have a power, so of course that negative is not going to go anywhere. A positive times a negative is a negative, so I'll have negative 4x. And then nothing's happening with the 5. Okay, now I'm looking up and I'm comparing this with the original 2. It does not match the original equation, but neither does it match the opposite equation. It doesn't match either of those, so that's why we go with neither. That's what you would have to do to show it algebraically. If you had to prove it algebraically, here's how you would finish it off. F of negative x did not equal the original function. F of negative x did not equal the opposite function, so we put neither.